Now that we've gotten a feel for solving multiple kinds of trig equations, the piece we're going to add is using something called identities. So identities are just facts about trig, they're qualities. So today we're just going to be looking at the reciprocal identities and quotient identities. You have really been dealing with these as you have been solving all these problems. And this is just using it to make a generalization into new perspectives. So first, the reciprocal identities deal with what trig functions go together. So for example, sine and cosecant, we know are reciprocals of each other. So that means sine of theta is equal to 1 over cosecant of theta. You can flip them. It goes the other way. Cosecant of theta is equal to 1 over sine of theta. So again, these identities are just true facts about trig, which means we can substitute using them. The next ones that go together, cosecant and secant. So we know cosine is 1 over secant of theta, and secant is 1 over cosine of theta. As long as you know the pairs that go together, you'll know these identities. And tangent and cotangent go together. So tangent is equal to 1 over cotangent theta. Cotangent equals 1 over tangent theta. So take a moment, pause the video if you need to, make sure you have all these reciprocal identities written as the notes portion from this video on the worksheet that you picked up. The other identities that we'll have in this section are called quotient identities. So quotient, you should know, means division. So essentially these are representing tangent and division. We know tangent is y over x. We also know y represents sine and x represent cosine. So that means tangent of theta is equal to sine divided by cosine of theta. And then it goes vice versa. Cotangent is the opposite. It's x over y, which means cotangent equals cosine over sine. So again, take a moment, write these in your notes. And identities are just true facts about trig. So now the way we'll use them to solve equations, you'll see in the next 3 examples. So this first example is just going to be a quick substitution. We have 1 over cosecant of theta is equal to 1/2. Well, using our trig identity, our reciprocal identity, we know that 1 over cosecant of theta is equal to the same as saying sine of theta. So we're going to use substitution, replace that whole piece with just sine of theta. Those are equal, so we can replace them. And then equal to -1/2. So the idea with using identities is we are using substitution to simplify an equation and make it easier to solve. Now this looks like all the problems we've been doing. So for sine to be negative, that means we're in the 3rd and 4th quadrant. Our reference angle for when sine is 1/2 would be 30 degrees. So our answers to this problem will just be the 30-degree angle in both of those quadrants. So the first one, 180 plus 30, will be 210 degrees. And then the second one will be 360 minus 30, which is 330 degrees. So once we simplify these just turn into the simple trig equations. It's a matter of using substitution first. So here's another example. We have sine theta over cosine of theta equals 0. So again, we have multiple trig functions in here. We can't isolate any of them at the moment. But knowing your trig identities, you want to recognize that sine of theta over cosine of theta is equal to tangent of theta. Again, that is just a true fact of between all the connections involving trig. So we can replace sine over cosine with tangent. And now we're left with tangent of theta equals 0. So again, this turns back into the problem we're used to. Tangent of theta is y over x. So for y over x to be 0, that means the numerator, the y, has to be 0. So look on your unit circle. Y is 0 over here at 1, 0. And to the left at -1, 0. So those angles are 0 degrees. And then 180 degrees. So again, the whole point of this is recognizing when you can substitute other trig functions in to simplify a problem. Okay, this last one's going to take a little bit of extra manipulation with it. So again, we have 2 different trig functions. We can't isolate either of them. So we want to figure out how can we manipulate the problem and then use one of our identities. And if we have sine and cosine, kind of your go-to is going to be, okay, how can I turn this into a tangent problem? Well, we know tangent is equal to a sine over cosine. And the reason you would think to go that direction is that's the only function that can let you sub out both sine and cosine. So if we want to turn this into a tangent, we want it to say sine over cosine. Okay, so if we look at this, we can manipulate a little bit. We want to divide cosine to both sides of the equation. Again, we're only doing this because we know if on this left side, if we can get it to sine over cosine, then we'll be able to substitute. So after we divide that out, we're left with root 3 is equal to sine of theta over cosine of theta. Now we know that sine over cosine is equal to tangent, so we can sub out and turn it into root 3 equals tangent of theta. So it takes that extra piece of manipulation to get it to that point. Now, solving it like our normal problem. Tangent is positive. First quadrant and third quadrant. We need our reference angle, and these are the ones that are a little harder to find. If we know y over x is equal to root 3, well, that happens. If you aren't sure, you just have to solve it out, guess and check with the root 3 over 2's and the 1/2. But that happens when you do root 3 over 2 divided by 1/2. And those coordinates, y is root 3 over 2, up at 60 degrees. So that's our reference angle. Sub it into our picture. So our first answer is just that 60-degree angle. And then the second answer is 180 plus 60, which would be 240 degrees. So as we get into these problems, there's going to be more messing with them, with manipulating them, and then substituting pieces out in order to get it to a basic trig equation. So now on that worksheet, go ahead and keep working through the practice problems and then just ask questions as they come up.